Hi students. So in this lab we're going to explore the isotopes of candium activity. And it's a very simple, straightforward lab. The idea is not so much to eat candy, although that's one of the benefits of it. We're going to explore how you calculate atomic mass, the funny number on one of the boxes in the periodic table. To do this lab, we have a Ziploc bag with a collection of candies. We have Airheads, Starbursts, and Laffy Taffies. Different numbers of each, and that's going to come into play in just a minute. We also have a handheld scale. This is one of the ones that you could either find in lab or even at your own house if you wanted to follow along. The procedure is pretty simple. What we're going to do is first identify and inventory the types of candy that we have. So let's dump out the candies and count them up. So I have 1, 2, 3 Airheads, blue raspberry, best flavor. 3 Airheads. We have 2 Laffy Taffies. Don't worry about the flavor. It's just a different. It's as if each type of candy is an isotope of the element candium. So we got 2 Laffy Taffies, different isotope. And we have 1, 2, 3, 4, 5, 6 Starbursts. Again, don't worry about the flavors, just the numbers and types of candy are what's important here. So 6 Starbursts, 2 Laffy Taffies, and 3 Airheads. Now, you'll want to write that down on the data table, the number of pieces of Starburst, Laffy Taffy, and Airheads. You should write in the first column of the data table, add it up to get your total. Now, percent abundance, simple calculation. If we had 6 Starbursts plus 2 Laffy Taffies plus 3 Airheads, how many is that in total? You do the math there. Then you simply get the percent abundance, take the number of a given type, say Starburst, if there's 6 of them, divide by your total, convert it into a percentage, and you can round to the nearest percentage there. Do the same thing for the Laffy Taffies, so 2 Laffy Taffs divided by the total, multiply by 100 to get a percentage. Airheads, 3 divided by the total. And then if you round each of those to the nearest whole percent and add them up, it should add up to close to 100. It could be 99 or it could be 101 due to rounding, but it should be really close to 100. Now for the fun part. We're going to weigh the candies. Now, you can do it the long way, which is to weigh each individual piece of candy and write that down and then take an average. Or you can do it a somewhat faster way, which is the way I'm going to demonstrate for you. Take all of the candies of a given type, put them on the scale, get the total mass, and then divide by that number. So let's start with the Starburst. On the scale, I'm going to hit the on button. Okay, so I've turned on the scale. If after turning on the scale you get a number other than 0.00, just hit the tare button, which is on the right. That means reset it so that the scale is calibrating a 0 reading with nothing on it. Let's take our 6 pieces of Starburst. You can place all 6 on there. And if you can read the number here, it says 31.00 grams. Let's write that down, 31.00. Next, to get in the lab table, in the data table, it's going to ask for the average mass. And it's going to, the mass number. So in the case of Starburst, we're going to take 31 grams divided by 6 and then record that result in the data table. We'll do the same process for Laffy Taffy. So we've got, after I take the Starburst off the scale, Laffy Taffy, there's 2 of them. We get 19.3, it's drifting a bit, 19.28 grams. So 2 pieces of Laffy Taffy weigh 19.2, now it's 2.7. It won't matter too much, but 19.27. Then what I'm going to record in this box of the data table where it says average mass or mass number for Laffy Taffy is 19.27 divided by the number of pieces, 2. So on your calculator, I want you to divide 19.27 by 2 and then record that result where it says average mass of Laffy Taffy. And then the third one, or third type of candy, Airheads. Notice that the scale is giving me a 0.04 reading, so I'm going to hit the tare button. There we go, and it should re-zero for us. And we'll place 3 Airheads on the scale. We get a mass of 34.22. So in the data table, where it says average mass or mass number for Airheads, write the result of 34.22 divided by 3 in that box. Okay, let's summarize the data that we've collected in this lab. First, on your data table, let's note the number of pieces of Starburst, which we had 6 of, Laffy Taffy, which we had 2 of, Airheads, which we had 3 of. And if you add 6 plus 2 plus 3, you get 11. Next, to calculate the percent abundance, take the number of pieces of a given type and divide it by the total. So for Starburst, I'm going to take the number of Starburst, 6, divided by 11. And you could take out your calculator, 6 divided by 11. Let's round it to the nearest whole percentage. So I'm then going to take 6 over 11 times 100%. And if I'm rounding that to the nearest percentage, I get 55%. For Laffy Taffy, we had 2 divided by the total 11. To make it a percentage, multiply by 100%. So 2 over 11 multiplied by 100, we get 18%, rounding to the nearest whole number. For Airheads, we had 3 divided by 11 multiplied by 100%. We get 27 if we're rounding to the nearest percentage. Now, let's add together these percentages just to double check. Are we getting close to 100? It doesn't have to be exactly 100. It could be 99, it could be 101. But if we take 55 plus 27 plus 18, we get exactly smack dab on the nose 100%. Okay, now, average mass. Our mass for the Starburst, all 6 pieces together, was 31.00 grams. And if you remember, there were 6 of them. So we divide that by 6. So on your calculator, type in 31.00 if you want, divided by 6. And we get an average atomic mass for this isotope of candium of 5.17. I'm going to round it the hundredths place. For the Laffy Taffies, if you recall, during our data collection, we had a mass for both pieces of Laffy Taffy of 19.27, and there were 2 pieces, so we're going to take 19.27 divided by 2, and we get 9.64 grams as the average atomic mass for that isotope of candium. And again, for the Airheads, same process. The mass for the 3 Airheads was 34.22 grams. There were 3 pieces of Airheads, so we'll divide out. And we get 11.41 if I'm rounding to the hundredths place. Now, we have a completed data table, and this is what I want you to work with when you answer the analysis questions. But I want you to consider that we've got at this point a percent abundance and a mass number for all three types of isotopes of candium. Let's see if we can use that to get the average atomic mass.